When there is an exponent raised to another exponent, we call this a power to a power rule. And whenever we have this power to a power rule, what we do is we multiply the two exponents together. So for instance, in this general rule that we have right here, if I have a to the b and then it is raised to the c, we would take b times c to get our answer. So if we take a look at number 32, see how it says m to the third to the second? That means we would multiply together 3 and 2. Well, 3 times 2 is 6, so this would give me m to the 6th. We take a look at number 33. We have y to the 5th, and then it is raised to, again, the negative 2. So we would multiply together the 5 and the negative 2. This would give me y to the negative 10. But based on what we just learned about negative exponents, we have to actually apply that negative exponent property to this answer as well. So because this has a negative exponent, we have to turn it into the reciprocal. So we would write our answer as 1 over y to the 10th. And that would be my final answer. If we left our final answer as y to the negative 10, I would actually have to deduct some points from your homework or quiz or test, because that's not actually the end answer. You have to then deal with the reciprocal. So if I take a look at number 34, same idea applies. Negative 2 and 5 multiplied together would give you a to the negative 10. But because it's a negative exponent, you still have to continue simplifying. So if we change this into our reciprocal, it would be 1 over a to the 10th. And that would be our final answer. Now if we take a look at number 5, I want you to put a star next to it again. Number 5, just because it has that base of 5 does not change the 5. Just like how we were talking about with like the 2's, the 3's, any other base. If it's a base, you cannot change that number. So what we would do is we would just multiply together the 3 and the 12. So we would end up getting a base of 5, but an exponent of 36, because 3 times 12 is 36. Now number 36 is an algebraic representation. So right here, if we look and we're multiplying together this 2 times that 3x minus 4, just like how we did on another problem, I would recommend writing this out, so that way you know what you're actually multiplying across. So I would say 2 times 3x minus 4. If you write it out, then you can actually see that the 2 needs to distribute to the 3x and to that negative 4. So the 2 times that 3x will give me 6x, and that 2 and that negative 4 will give me that negative 8. So my new exponent is 6x minus 8, but my base is still that k. So I would have k raised to the 6x minus 8. Why don't you go ahead and try number 37 and let me check it.